Okay, so on to question 2. How can I determine the Van Hoff factor of a substance from its formula? Okay, so first I'll just write down the definition of the Van Hoff factor. Which can be denoted as I. This is the number of particles formed in a solution from one formula unit of a solute. So depending on whether or not you have a non-electrolyte or a strong electrolyte, this will affect the Van Hoff factor. So for example, for non-electrolytes, so non-electrolytes are when ions, when the solution doesn't separate into its ions, or the solute. I'll just write that down. So non-electrolytes, they don't separate into ions in solution. So these are like non-conductive metals, and their Van Hoff factor is typically equal to 1. And when you have a strong electrolyte, like sodium chloride, its Van Hoff factor is greater than 1. Okay, so let's see what the junior tutor said. The Van Hoff factor I is the number of particles each solute formula unit breaks apart into when it dissolves. It can be determined depending on the type of solute, non-electrolyte, or electrolyte. For non-electrolytes, the solute will dissociate into ions, therefore I is equal to 1. For example, sucrose. For strong electrolytes, I is greater than 1. For example, sodium chloride will dissociate according to the reaction NaCl makes Na plus Cl minus. Thus, I is equal to 2. For magnesium chloride, it will dissociate according to the reaction MgCl2 makes Mg2 plus 2 Cl minus. Thus, I is equal to 3. So they're pretty much counting how many ions forms after it is dissociated into the solution. For weak electrolytes, I can be calculated using the ICE table. So they have an example using the weak acids, HA, that dissociates into H3O plus and A minus. And the ICE table stands for initial, which is the initial concentration. So notice that the reactant starts off with a concentration of 1, and two products start with 0 because they aren't formed yet in the initial reaction. The change is how they change in concentration, and then at equilibrium, 1 minus x and for the reactant, and the products are just x. So at equilibrium, the total number of moles is equal to 1 minus 1 x, in brackets plus x, which is equal to 1 plus x. Yep, so those are all the ways of finding the Van Hoff factor. So the solution is correct.